Electromagnetic induction is when a conductor, such as a coil, cuts through the magnetic field lines, the lines of flux of a magnet, and that effect creates an electromotive force, an EMF, and that can cause a current to flow in a wire. And that's what Michael Faraday discovered nearly 200 years ago. So you can create a generator, an electrical generator, using the setup we've got here. And this is a rotating coil generator. We need to label it and describe how it works. And this simple kind of setup is used in generators which are such as used in your bicycle dynamo. They are called AC generators because they will generate a current, an alternating current, AC, alternating current, that will be flowing backwards and forwards depending on how fast this coil rotates. So let's take a look and label up this diagram to start with. So first of all, let's just add on a detail here, which is what's called a brush. It's a slipping contact, because these slip rings are going to be rotating as the coil rotates. Let's label things up here. So these are called slip rings, and they're attached to the coil. So as the coil rotates, these slip rings will be rotating as well. And these are called brushes or slipping contacts. Slipping contacts. We have the rotating coil, and we're turning this coil by an external means. Maybe we might be turning this manually, or it might be, just as in a power station, a turbine that's been driven by steam, and we're feeding that to a generator which is turning a coil. And of course we have the external magnetic field, so we can just label that the magnetic field or magnet. And north and south poles. So how does it work? Well, number one, let's do it in 3 steps. First of all, the rotating coil cuts through lines of flux, and these are the magnetic field lines which go from north to south. If we were to put those in our diagram, they would look a bit like this. Okay, and they're at right angles at the moment to the direction that the coil is rotating. So number 2, this cutting effect, this cutting of flux, induces an EMF, an electromotive force in the coil, which is a fancy name for a voltage, a potential difference. And number 3, the induced EMF causes an alternating current to flow in the circuit via the slip rings and contact brushes. And this is a basic AC generator. basic alternating current generator, or otherwise known as a rotating coil generator. Hope that makes sense, and we'll be looking in a bit more detail as to how the current flows in this external circuit. And of course, if current flows in this circuit, we'll be making this light light up. We'll be looking at a bit more detail in the next couple of flashcards. See you in the next one.